I'm Alan Wartes, and this is Think Radio Presents Think Planet. My guest today is Professor of Biology and Botany, Jonathan Coop.
Science is the best tool humans have ever come up with to gain unbiased information about how the world works. And we've never had better science that tells us about the way things are going, how things are, and where they're likely to go than we do right now. So this is the most scientifically well-supported, these are the most scientifically well-supported inferences that we've ever had access to.
Welcome to another great conversation on Think Radio.
Think Planet is made possible by support from the Western Colorado University School of Environment and Sustainability, empowering future change agents to foster ecologically resilient, economically sustainable, and socially just communities throughout the world.
If you like Think Planet, then I know you'll enjoy the other shows in the Think Radio Presents family of podcasts. Think People, a celebration of just how amazing people can be. Think Business, a weekly discussion with entrepreneurs, innovators, and disruptors on sustainable business into the 21st century. Subscribe to Think Radio Presents on iTunes, YouTube, or wherever else you get great content. And don't forget to help us spread the word by liking our social media channels and sharing the content we post. We're grateful to have you in the conversation on Think Radio Presents. My guest today is Dr. Jonathan Coop. He's a biologist and a botanist specializing in forest ecology in the Rocky Mountain West. He teaches undergraduates at Western Colorado University in Gunnison, Colorado, as well as Master of Environmental Management students in the master's program there. In his own words, Dr. Coop describes his academic focus, among other things, as including an understanding of human influences on ecological systems, and also on management for a future of certain change, but of a less than certain direction and magnitude. In a recent email exchange about what we might discuss today, Dr. Coop wrote that while he certainly could talk forest ecology all day long, his favorite topic is, I quote, evolutionarily how Homo sapiens got into this mess we call the Anthropocene and how we might find our way back out of it. Stay tuned. Jonathan, thanks for joining me today.
Sure. Thanks for having me, Alan.
Listen, in light of what I just read, my first question to you is, you do realize we only have a half an hour together, right?
Yeah, and I also realize this may not be the best setting for the sort of deep discussion that I was angling for.
Oh, no. It's the perfect setting, all right? You are exactly the right place.
Sure. The only thing that's missing is a campfire and something cold in my hand. And
okay. Yeah, well, we hit pause and go get those things for you want.
All right.
No, I think this is the perfect setting. I mean, it's after all called Think Radio, right? We're challenging ourselves to think deeply about not just the surface of things, but what goes on under the surface, the how and the why of the world that we live in. And so I'm delighted to have you today. And I can't help noticing, though, that really anyone who has decided to be a forest ecologist these days picked quite a time to embark on that field.
It's an interesting time to be a forest ecologist, absolutely. And that's also a euphemism for saying that it's kind of a disturbing and depressing time to be engaged in this line of research.
Well, yeah, because it's like the ancient Chinese curse, may you live in interesting times.
Yeah, it is, yeah.
Well, so, knowing that we don't have all day, give us the elevator pitch version of what it is that you're seeing, why you say change is certain, and why you are led to say that it's disturbing and depressing in some ways.
Sure. How tall is this building? How many floors do we have for this elevator pitch?
Let's see. It's
are we in Gunnison or some large
city? Let's give ourselves
city?
the Empire State Building. Okay, so that's
sure. Where to begin? So I mean, we know that ecological systems are dynamic and they change over time. We also know that as they change, we say there are winners and losers. There are species that do well and species that are going to do poorly, given any kind of change that gets thrown at an ecological system.
And that happens in the best of times.
Yeah, but generally that happens over a different kind of time scale than the time scale we're operating on right now. And so basically what we have done, directly, indirectly, inadvertently in some cases, is really altered the dynamics of almost all of our ecological systems on the planet through how we land use modifications, land history. So in forests, through our history of grazing that changed the availability of surface fuels that carried surface fire, to direct fire suppression, to the sort of logging practices that we've used for a century or so. And then those things have all driven very profound changes in how our forested systems are working relative to sort of pre-European settlement baselines. And now on top of that, we've really thrown climate change into the mix as a very powerful force that is pushing systems very rapidly in entirely different directions. And when you put all that together, we sort of have the perfect storm of the potential for very rapid and really dramatic changes to unfold across our forested landscapes, particularly in the western U.S., where maybe some of these landscapes were already kind of on the edge as far as drought and things like that, and natural patterns of fire and insects. So, you don't have to look very far in Colorado to see dead trees and to see a lot of dead trees. That's what we're dealing with 1 to 2 degrees of Fahrenheit beyond where we were.
On top of many decades of changes that were already changing the way forests work.
Right. And, if you look down the road, well, if that's what we're seeing now with just a couple degrees, what are we going to see with 5 or 8 degrees of Fahrenheit warming? What are we going to see with, the kinds of, like our summer now, this extreme drought that we just have basically been going through and still are in, that sort of being the baseline or the norm, that could represent the average conditions, in the not too distant future.
And let me stop you there, because you're not just being overly gloomy when you say that. I mean, there's research that suggests this is exactly the trend that we're in, right? Speak a little bit about that.
Absolutely. I mean, this is I'll put it this way. Science is the best tool humans have ever come up with to gain unbiased information about how the world works. And we've never had better science that tells us about the way things are going, how things are, and where they're likely to go than we do right now. So this is the most scientifically well-supported, these are the most scientifically well-supported inferences that we've ever had access to. Now, science is a process. We're always learning new things. But generally, the things that we're doing are quantifying with ever more precision how dramatically different the future is going to be than where we are right now.
So the whether or not this change is taking shape in general form the way we've seen it so far is really not a question anymore. It's not a matter of magnitude. It's a matter of timing. Magnitude
and rate.
Well, let's go back there a little bit though, because you're a trained scientist. Mm-hmm. My degree's in geology. I've studied the scientific method, and I really do have an appreciation for how rigorous that process is. Most people don't, though. I think most people don't quite understand just how difficult it is to get a scientist to actually come out and declare something. It's always, you said the word, it's always a process.
Yeah.
And yet, here we are in this day and age where, I don't know, depending on the figures you use, something like 97 or 98% of climate scientists, for instance, in the world are willing to say Yes, anthropogenic climate change is happening. It's real. We can see it. We can measure it.
Mm-hmm.
How rigorous a standard is that to get that percentage of scientists willing to agree to something?
It's basically taking the some of the smartest people out there. I mean, these are people who've dedicated their lives to the pursuit of science, right?
Right.
And it's incredibly difficult and incredibly competitive process to go and get your PhD and go and do postdocs and get a job where you can actually do science. I mean, it's a very competitive process. And so we have, thousands of scientists who are among the best that they're in the world as far as their capacity to do this sort of work. They have access to, gigabytes and gigabytes daily of data from satellite measurements, from all sorts of sensors, temperature sensors, climate data on Earth.
Right, a data stream that is only growing by the day.
Incredible computer power, incredible power to model the kinds, model these systems.
Right.
And I think it's not something to take lightly. And when you have such broad agreement among those people that all of the evidence and everything that we're seeing is consistent with this, hypothesis or theory that humans are driving climate change, and that theory is internally consistent as well. We know we're emitting carbon dioxide, right?
That's measurable.
I can measure it. I put, I fill up my truck with gas, and later on that gas is gone. Where did it go? Well, it turned into CO2 and went into the atmosphere. We can quantify that very well. We know just based on physics how carbon dioxide works in the atmosphere, how it allows certain wavelengths to pass through and other wavelengths are basically reflected.
Again,
right?
totally measurable.
Yeah, and this is physics. It's hard to argue with that.
There's nothing speculative about that.
Right. And so you put those two things together, and you have a hypothesis. Well, you put those two together, we should expect the temperature to warm up on Earth. Lo and behold, that's exactly what we're seeing, right? Well, we expect that might drive ecological changes and social changes and all sorts of other changes, and those are the things we're seeing as well, right? So it's pretty hard to argue with based on data and sort of an informed and sort of rational understanding of how these things are related. Does that make sense?
Yeah, well, it does, and because scientists really are a lot like siblings in some way. They don't agree on much of anything. There's always something to argue about, right? And so when you get this kind of broad
scientists are
agreement.
we're also, I would say, among the most skeptical people that are out there, right? We're trained to be skeptics. I think we're inherently skeptical.
Yeah.
And we don't accept anything without a very high standard of proof, right? So we take a look at what the evidence says, and then we draw our conclusions based on that, right? So, climate change skeptics, like scientists are the most skeptical people there are, right? We have a systematic way that we're skeptical, and we don't, we either reject ideas or accept them. And even when we accept ideas, it's not a belief that's set in stone. It's accepting, hey, well, until we can show otherwise, this is where all the evidence is leading us.
Well, let's bring that conversation back to forests then, because based on what you can measure and what you can see and what you feel that you could achieve broad consensus on in the scientific community, how are our forests different now than they have been in the past?
Well, all the evidence tells us that in many settings, our forests have a dramatically altered fire regime because of our history of land management that primarily involves suppressing fires. So in many settings, we just simply haven't had enough of the kinds of fires that forests were adapted to maintain their structure and composition, to allow fire to have continued to play its sort of natural role in these systems. So in many areas, we have forests that are much more dense and contain fewer large fire-resistant trees than they did prior to European settlement, right?
Mm-hmm.
In some areas, we know that, well, their high elevation forests always had a lot of trees and a lot of fuel. So those forests are not necessarily at any given location going to be that different from how they might have been. You know, if they only had fire every 300 years, well, another 100 years on top of that isn't going to change things that dramatically. But what it does change is the patchiness of the landscape and how much sort of early successional or young forests we would have had at in those higher elevation landscapes,
Mm-hmm.
right? Because without fire suppression, we probably would have had lots of small patches that had burned at some point in the last 60 years or so, right? So those are two big changes. On top of that, we know trees are much more drought stressed across the board than they have been at any time, you know, in many hundreds of years.
And you're speaking about the Rocky Mountain West now. Yeah.
Because of it's warmer, and when it's warmer, the atmosphere can pull more, you know, the atmosphere can hold more moisture, and it pulls more moisture out of the biosphere, out of the forests. So the warmer it gets, the more this thing called vapor pressure deficit increases, and the more that tends to suck moisture into the atmosphere. So things get drier even without change in precipitation if it gets warmer.
Interesting. That seems counterintuitive. The atmosphere is actually able to hold more moisture,
Mm-hmm.
but what that means for the soil
It means
for
it pulls
fuels
it.
on the landscape is it pulls it from
The atmosphere is always trying to pull moisture out of stuff. Like if we dump this glass of water on the table in Gunnison, you know, we could come back in a couple hours. It'd probably be dry, right?
Yeah.
So the warmer the atmosphere, the more rapidly it would dry that out, right?
Mm.
So that's changing. That's also resulting in drier fuels. So when we're more likely to have. It's easier for fire to burn fuel when it's dry. Mm-hmm. That's another common experience amongst those of us who.
Most of us who've tried to burn green wood at the fire at the campground could attest to that.
And on top of that, we've seen an increase in the length of fire seasons. So even if nothing else had changed, longer fire seasons mean you just have that many more days for a rare event to occur, and the likelihood is you're going to have more of those events. So an ignition that might occur 1 out of every 100 days. Well, if your fire season goes from 40 days to 100 days, you're much more likely to have that fire start.
Right, and that's happening because snowpack is developing later
and
melting off earlier, and less of it to begin with.
Yeah. So basically we have a longer season for fire, drier fuels, and warmer temperatures during those seasons. Mm-hmm. So we're seeing a lot more fire.
Okay.
That's just fire, On top of that, we're seeing higher rates of tree mortality just because it's drier, that we think they're more stressed in general.
Mm-hmm. Does that make them more susceptible to disease?
Yeah, and then absolutely, that's the other thing we're seeing is a lot more really large-scale insect outbreaks across our forests, across the western U.S. I mean, from Mexico way up into British Columbia, Alberta, Yukon. I mean, we're seeing really dramatic insect outbreaks that are resulting in really massive changes.
And compared to what you can see in the historical record, put that into context. Are these like historic events?
Well, yeah, the historical record, I mean, this is where we can say, well, within our period of recorded history that we've been measuring things, all this stuff is happening at an unprecedented scale and rate, right? But, if we go, then it gets harder to go back in time. We say, well, over the last 100 years or so, we know these things are really unusual. If we go back farther in time, we start to lose the ability to, we can say, well, if we can reconstruct forests ages and when they were established based on how old those trees are. So maybe we can go back and say this forest, is 300 or 400 years old, even though we weren't around there to witness its establishment. We can record that. We can get data on fire scars on trees that go back hundreds or even in some cases thousands of years and say how much fire was there. But the farther in time you try and go back, the harder it gets. And we can go look in ponds and find pollen that's 10,000 years old and say, well, 10,000 years ago, this is what was here. So,
but on a time scale that you're describing, then you're comfortable using the word unprecedented.
Absolutely. Yeah. On the time scale that we know about, right? And I think it's also important to think about, well, what's the time scale that actually matters to us, right? Because sure, we could go back in the deep geological past and say, oh, well, a meteor hit the Earth 65 million years ago and fucked everything up. Well, that's true, but is that the baseline we want to be using to? is that the thing we want to be comparing ourselves to? Sure, it's hard to imagine that life won't go on in some shape or form.
Right.
But is that the future that we want to be counting on? Or shouldn't we be thinking, hey, I kind of like certain things the way they are, and it's likely that my kids and my grandkids and their grandkids will also value those things. That's the time scale that's relevant for us.
Well, and so that brings us to a word that you used in your email to me that I read a little bit earlier, and that is evolution. From an evolutionary point of view, you say you like to consider these things.
Yeah.
Why would you use that word in this context?
I think that what I think is interesting, and I think what I was alluding to there was that evolutionarily, let's sort of pick some arbitrary starting point for our species. Maybe it's about 1 million years. You could go back and say, well, we really diverged from our common ancestor with chimps 5-6 million years ago, but we weren't really humans until the last, let's just say, million years, right? Over that 1 million year time frame, and if we think about maybe on average people had kids when they're 20 or something, that'd be 5 generations every 100 years. We have to figure out the math here. It's 20,000 200,000 human generations, let's say. Over that time frame, most of our evolution, or most of that time frame was spent, let's say, small family groups of humans sort of wandering the landscape, foraging for food, hunting, learning how to use fire.
Right.
But fundamentally, it was the last 10 to 10,000 years has just been a very, very different period for us, right?
Mm-hmm.
And in some ways, the lives that we're living and our lifestyle, let's say our lifestyles are in some ways kind of incompatible with what we evolved to do well, right? And there's a reason we have all the things that we have when we live these nice, comfortable lives, because it's nice and it's comfortable and I can eat whatever I want, right? But if you look at diet and exercise, the amount of exercise and the kinds of diets that most of us eat are nothing like really what evolution prepared us for. And so we've got all these back issues and carpal tunnels, and we're sitting in our,
Mm-hmm.
So even at that level, we could say, boy, evolution didn't necessarily really prepare us for just some of our basic features of our lifestyle, right? But I think most fundamentally, we're not really necessarily that well prepared to live in a world of 8 billion people, with the capacity to essentially permanently alter the trajectory of this entire planet, of its climate, of the evolution of all the other species on this planet, of our own evolution, right? Evolution didn't prepare us to have the kind of power to create massive changes over short time frames that we have right now, right? I don't think it prepared us to live in a global society. In some ways, it's so I think there's
it's certainly different from the vast majority of time that we've spent on the planet.
Yeah.
And what you're describing seems to me to be a kind of paradox, because on the one hand, evolution did provide us with the kind of brain that has allowed us to adapt our environment such that there can be 8 billion of us on the planet. Maybe not well.
Yeah.
But here we are.
Right.
That was an evolutionary endowment.
Sure.
And yet you're suggesting that at the same time, that's not enough to necessarily carry that adaptation forward well. Am I characterizing what you said well?
Yeah, more or less. Let me use another sort of example here. If you opened up that door and there was a large predator, a lion, let's just say, right outside the door, you would immediately, I'm assuming I would, panic, right? I would immediately get a huge jolt of adrenaline.
Sure.
And I would respond, right? If you're watching TV and you see terrorists fly a plane into a building in New York City, you're going to get maybe not quite as extreme of a response, but you're going to feel the need to respond absolutely viscerally, right?
Mm-hmm.
And society will act on that. If a scientist tells you, boy, humanity, you are changing the planet in a way that is going to be potentially really awful for you, for your descendants, but you can't see that. And it's just, well, I've got to trust this random scientist to tell me that. I'm not seeing this unfolding with my own eyes. Maybe there are some clues out there if I look, but I could also turn to, some webpage and find all sorts of reasons to think that's not happening based on, what the Heartland Institute tells me or whatever. You're probably not programmed to respond. And I think in a way that's sufficient to meet the scale of the threats that we're facing.
So historically speaking, threats that individual humans faced were of an immediate nature. You either had a predator or, the food was running out, right, or something that you could respond to materially right now. You're suggesting that complex problems lend themselves to being ignored?
It's easy to ignore it because it doesn't affect you right now or your kids right now or your wife. It doesn't affect you right now. So it's easy to think, well, it doesn't. We're not programmed to respond in the way that might actually be suitable given the enormity of the kinds of changes that we're causing, right? And the same way, I think, with if you're in a small family group and you see someone in that group who's suffering immensely and doesn't have food, you're going to take care of that person, right?
Yeah.
If that's someone on the other side of the world, it's again, it's not in your face. It's not in a way that you're necessarily going to respond to adequately.
Well, and
right?
you might still have the same feeling, but your capacity to respond to it is
that's true too.
Very much diminished.
Well, it would take a collective response. It would take a society that worked together. You know what I'm saying?
Yeah, a mobilization of resources and energy that.
And there are people who do respond. I'm not just saying you don't respond.
Right. No,
there's so much going on, but it's just the idea is that, boy, we're not really dialed to react to things that aren't right in front of us. And the kinds of issues that I think are most problematic for us right now as a species are the ones that we're not necessarily, primed to respond to.
Well, we have a moral imperative to not leave it there. So my next question to you is, what can the average person do to begin to wrap their heads around what you're saying?
Yeah.
But more importantly, to imagine a different way of living so that we do make progress.
Right. Well, that's the $1 million question right there.
Yeah. What are your ideas?
Taking a good, hard, unbiased look at the information that the scientists are trying to provide society, right? And that's a two-way street. And I think scientists are realizing we need to do a much better job of communicating with people who aren't other scientists, right? But I think that, education is key, and that's why I'm in the business that I am. That's why I teach classes, and that's why I do what I do. And then I think beyond that, there are all sorts of actions that anyone can take that will be useful and helpful. But at the same time, a small group of people making individual taking individual actions may or may not add up to the sort of large-scale changes that I think are necessary, right?
And so you say there are all sorts of things that people can do. Name three that aren't the same old things that we've heard over and over again. Okay, as wonderful as it is to recycle your garbage, I don't want to hear that anymore.
Okay,
I want to hear something that's proportional to the imperative that you've laid out here. What can people do, and in particular, how do you think people need to change how we think?
Sure.
In order to even begin to address these issues?
Yeah. Well, that's a great question. And sure, we know there are all sorts of small sort of individual actions that we can take that do add up to something greater than the sum of the parts, right? But you don't want to hear about recycling. Or I would say that we know there are individual actions that, if adopted at a large scale, will lead to changes, right? And cultural changes can happen even without everybody getting on board. It just takes that critical mass. But fundamentally, the scale of these issues does not lend itself to a handful of people who are sort of wealthy enough and educated enough to take individual action to change the world, right? And so fundamentally, it takes a societal response. It takes policy. It takes, global connectedness and, global level policy changes fundamentally, right? We're not going to get anywhere with whether you recycle or not. Now, you recycling, I would argue, is probably a good thing for you to do.
Of course.
But it's easy to also say, well, I recycle, I do my part. And no, in fact, you haven't really contributed that much, right? Mm-hmm. So I think that it does require a response. It requires changes in our infrastructure. It requires changes in governance in which, in a democracy, you have a responsibility to try and make that happen, right?
Right.
Say, as far as like changes in how we think, I don't know necessarily how to catalyze those changes, but I do think it requires a changing in how we think, and thinking that actually addresses the scale of these issues. And that may be, for any individual, what can they do? But really, what can you do? Where are you most effective? And this is what I tell students, there's lots of opportunities to make a difference and to go out there and find that opportunity.
Pick one, basically.
At the same time, the way I see it is a lot of this stuff, I would like to believe that we are going to make a lot of these changes. And so it seems just as likely to me that we will than that we won't. And all it takes is enough people sort of pushing for them and getting on board to kind of create that critical momentum, create that critical mass, right? And I think just being a part of that, when people in the future look back on you in your life, it would be great if they're saying, well, that guy he was on it. He was pushing for those changes,
Yeah.
He was one of the early adopters who was really pushing the envelope. And look, we can thank those people for their good work.
I recently had Dr. John Hausdorfer in for a conversation, and we're talking about his upcoming book, which is called What Kind of Ancestor Do You Want to Be? And that's what you're talking about.
Yeah. And I actually there's a famous botany professor when I was a grad student in Madison called Hugh Wiltis, and he would always end his class, and that's what he would ask the students: what kind of ancestor do you want to be?
Mm-hmm. So do you agree with this, that for most species on Earth, maybe all other species on Earth, evolution is an involuntary process? But what you're describing with changes in how we think is really a challenge for the human species to become the first in Earth history to voluntarily shape our own evolution.
Right. I would say that we're doing it involuntarily, and we're likely to start directly. It's not long before we'll be using CRISPR to modify our own genes, and certainly the genes of our unborn children, right? Mm-hmm. So we're headed down that road. To me, it's kind of scary, but I do think that there's biological evolution, and then there's cultural evolution.
And cultural evolution is really where my question was headed.
Biological evolution is not going to save us. Cultural evolution could. And
that's unique in the history, the natural history of the planet.
Yeah.
There even is such a thing as cultural evolution.
That is absolutely our most unique gift that we possess, right? We can learn from one another and transfer information, horizontally between two people rather than waiting to pass it down, whether or not that particular, progeny bearing that mutation survives or not.
Or
right?
wants to hear
it. Yeah. Right. Absolutely.
Yeah. Well, that's the challenge. That's the imperative. Final question. You characterized this as a 50-50 proposition. Why are you that optimistic?
Oh, sure. Well, so this is the scientist in me, I guess. I don't know enough to know whether or not it's a 5% chance that we, make it to sort of a good future for all of humanity, or a 90% chance. I really don't know. I've been surprised at how quickly things can change just in my lifetime, culturally. And if you just look back over the last 10 years, there have been some fairly major, cultural steps taken in our country and here in Colorado that no one would have necessarily foreseen, right? So it doesn't necessarily so things can happen quickly once you achieve that critical mass. And so I really don't know if we're totally screwed, or there's a glimmer of hope, or actually we might have a shot at this. I really don't know. So 50-50 is just me not having any clue, but knowing that fundamentally it should be possible for us. All of our problems of our own making, right? It's not like that meteor is coming at the Earth and we're like a T-Rex sort of looking up at the sky and having a sense of foreboding and not knowing why, right?
Right.
These problems of our own making, and they all have solutions that are not really that technologically complex, right?
And so it's time for us to prove you wrong.
Okay.
That we can adapt on a time scale and at a magnitude that's necessary.
Yeah.
I'd like to believe so.
I sure hope so.
Let's leave it there.
All right.
Jonathan, thanks for joining me.
Yeah, for sure. It's a pleasure.
Thanks for watching. Join us next week for another great conversation on Think Radio Presents Think Planet.